an ethoxide, you have that hydrogen creating an alcohol.
Okay. So why didn't it eliminate from the other side? You have your double bond on one side. Why isn't it on the other side?
Because of the methyl group. It's not a good leak. I mean, it's not even.
Well, no, but I'm talking about the beta position carbon. Does everyone see what I'm talking about?
Yeah.
Yeah, it should go to the more substituted one because it's a smaller base. If it were a large, like TB oxide,
Then it would just.
Well, so you look at that and you look at the hydrogens on the beta carbon, but you have to see if there are any that are anti, which in this case there aren't.
Have to go to the other side.
So you have the right product. It's just like, that's like the thought process. You're looking at the hydrogens on your beta carbons.
Okay.
And so, if you're like looking, because there are like two ways this will eliminate, right?
Okay.
So like, if you're leaving groups here, it'll eliminate this way or that way.
Okay.
And so if you have sodium ethoxide, which is a small base, it'll prefer to go to the more substituted side. And so this is what you look at first. You look at the hydrogens here, but the only hydrogen here would be a wedged hydrogen. And you have to have anti from your leaving group. And so since there are no dashed hydrogens on this one, the only way you could eliminate it is over here. So like if it could, it would prefer to go that way, but it just can't because there are no hydrogens there, so it'll go this way instead.
Okay.
So it's like, because like the one over here was the example, or the first one we did, was like, if it had worked out where it goes to like the more substituted one here, and this one has the dashed hydrogen, but that one doesn't have that, so it can't eliminate that way, so it has to go the other way.
So that's, okay.
Everyone see? Nice. Good product. Zaitsev. Good. So for
Would it still be called that though? In that situation?
Yeah, in that situation it would.
Yeah.
But I mean, technically it's the only product I think that'll form.
Yeah, well, yeah.
So you don't really.
Yeah, you would
You
really
would specify
specify
that?
it, yeah.
Okay.
So 4C? We do 4C. Mark it.
Oh, well, no reaction happens.
No reaction happens.
No anti-paraplanar beta hydrogens
No anti-paraplanar beta hydrogens.
to the leaving group.
And just to draw the compound up real quick, it was
That's how you draw it.
that, right?
At least I guess.
Huh? Probably.
So when she asked like the product or everything.
Yeah, if
What
she's
do we
the
put
target.
So that's how you try to use it.
But in this case, I was only asking the elimination. So,
Because the only reason it favors elimination is like how quickly elimination happens.
yeah.
Mark's the one that.
Except the primary, in which case that's.
Well, you started taking these, I was like, you know what?
But if we
I'm not being able to do it, that's a good idea.
Well, in this one, the only product.
Yeah.
Yeah.
Okay. So 4D.
We have the big base,
I know you are.
which is oxide, the leaving group leaves, bromine,
Okay.
the hydrogen attack, the positive cation to form the Hoffman product.
Did everyone see what he said?
It's on the left side in green.
Left side of the green one. It's a little bit harder to see, but he has TB toxide eliminating.
He was going for the irony of drawing a large face. Really small bit.
So you're saying once the, whoa,
Would you mind going up and explaining the mechanism for him, Ryan?
Yes. I don't know the mechanism.
You should know the mechanism.
Me too.
That's probably good practice.
I don't like the.
It is.
I gotta see the mechanism too. I think I know it.
I'm good.
It's 3 arrows for S or U2. Okay.
Actually, you draw it all as one step.
Yeah.
So you can do it from the start.
But isn't there no beta, I mean, isn't there no anti-paraplanar hydrogen right there?
Go for
That's what I was sketching.
the hydrogens on your methyl group, right? Because that's the hydrogen you're gonna take from.
There's 1, 2, that's it.
Yeah.
There's 1.
But that's the hydrogen.
Oh, right.
Yeah.
Oh,
Again,
yeah.
the TV's oxide
Yeah,
is
it was-
hydrogen.
Brain farting up the ass right there.
Or
There you go. Nice.
Goes both ways.
Okay, so would you mind explaining now? What you got?
So like the leaving group left, and then took oxide, attacked the hydrogen bond broke to the methyl, forming methylene.
Look good?
No, a quick question. Like, when it's ene, you know, like an alkene, I know when you're naming alkynes, you just use nonene or, you know, whatever the but if you're doing, like, alkene, you do, like, non-diene or something?
So what your question is, what's the ending for an alkene?
Yeah. Is it D-I-E-N-E or something?
Well, if you have two of them, then you start adding di, tri.
Oh, right.
Because alkynes, the ending is "ine,"
Yeah.
and then for these, it's just "ene."
So like, say there's one alkene in a pentane, would it be pentene?
Yeah.
And then you just have to put a number to say like where it is.
Okay, so then it'd be like well, yeah, so it'd be diene if it was two. alkene.
It'd be
nomenclature
pentuene.
part of the-
Okay, yeah, I kinda, yeah, I brushed up on it.
What's up,
If it had it on the cycle,
Would you go by the?
Oh, if it had
large
two.
chain,
These
or
are
would
kind
you
of
go by
unique.
the alkene in naming that?
Would you go by the large chain or the
alkene.
alkene?
Like, would you call it one cyclohexyl,
So you trimmed your beard.
Yeah, a while ago.
Or cyclohexyl.
Okay.
No, because
No,
one of them,
methylene.
so it'd be like,
it's attached to it, so.
or just do call it methylene cyclo.
You won't have something like that as a nomenclature one, because she didn't put anything for like a direct ring, thing like that.
Yeah.
So
Well,
you won't
'cause
have one like that, but those
typically-
ones are a little bit weird. You would want to name them based off of the priority of the substituent that you have, or the functional group. So I think in this case, it might be cyclohexylmethylene, but that's something you might want to double check with Dr. Dudes if you are interested in, but I don't think she'll ask you though.
Oh, yeah, so yeah, for 1B, is that what you guys are talking about? No.
Nah, we'll go back to 1B though, in a little bit. We're just gonna keep going forward.
Yeah, no worries, I was just, alright, yeah.
For sure. But one that has one similar is, I think, 1E, bro.
Huh?
1E, I think, is one that's similar. But anyways, number 5. Would you mind doing number 5, Corey?
So I don't know if I can explain it well in words, but I think I know what I'm talking about at least.
That's fine. Explain it how you think you know it.
So based on whatever reagents you use, it has to be located at specific atoms, whether you're breaking or forming the bonds. So I put up an example. There's a methyl group on a propane. There's also a bromine on the second one. So if you use the small base, then you can eliminate the bromine to create a double bond next to the phenyl. But if you use a large base, it has to go to the away from the phenyl. So it has to use the specific atoms either towards the one on the phenyl or away from the phenyl.
But why does that have to go away from phenol? It's a big boy.
I thought selectivity was like if you use one thing and then just like by the nature of the thing, it chooses which one to go.
I did it different. I use like HBr, like peroxide, like the anti-Markovnikov.
Sure.
Isn't that regioselective?
I think so. Yeah. It has to do with like what region it'll basically go on. So I think that's what you were also saying, right?
Yeah, which is, cause like in his example, he uses two bases to show like which way it could go.
Yeah.
But I thought like it was more like you show one base and then you're just showing like which one using that base it would prefer.
If you want, you can write it up on the board
It
and
just
give us your
says
explanation of
define
it.
regions.
I mean, this is, I asked you like your definition of it, So I mean, I think, I see where he's coming from, like it's selective on which region it's gonna go. The double bond. Yours is similar too with like more like functional groups and like PRs and stuff like that.
So the regioselectivity depends on, or can be used for elimination and addition?
I think so.
Okay.
Should.
We were just on elimination,
You, like, you think so?
Well, because I
Can I
think
get that
when we
survey
talk
back?
about.
Oh, usually it doesn't involve addition, but basically, elimination.
Right after.
Should we go on to 7?
Oh, 6.
6.
How about we go for 6 and then we start on 7?
Not jump ahead. Not jump ahead,
Ryan's
right?
been like, let's skip this until the beginning, it's gonna be over by the time we get to the good
I
stuff.
know.
Have it.
We'll hit the good stuff right now though.
Let's just skip it then, yeah, that's true.
No, we'll just give for 6 a shot. That'll be all.
That's just, so for stereospecific, that's like if you have a reaction that could have stereochemistry, or like the result has stereochemistry. So in this case, you've got like, with alkenes, you have like E or Z. With alkanes, you might have like R and S. But like in this case, it's something that results in like only one thing. The reaction can only produce one of the stereoisomers, and so it's specific to that isomer. So in this case, there's only, like if we're doing these, because we're doing the anti-paraplanar eliminations. So you go through here, I drew the Newman projection to show it. And the only way you can eliminate is when the hydrogen here is anti to the leaving group. And so the only way this will end up giving you is the E isomer. And so that's like, this reaction would be stereospecific because it only gives you the E one.
So when you're drawing it, I'm kind of sketchy on this part. So when you're drawing it, when you remove it from the new projection, then you see that.
So when you go from here,
Yeah,
like how do you draw the?
yeah, because
So like all I do is, I imagine you draw the double bond here, like where it's eliminating, and then I just draw in everything accordingly.
and then you see that they're both on opposite sides.
Anything that's opposite, you draw trans. So ethyl and methyl are on opposite sides, so you draw them trans.
Yeah, so like basically I just draw it like
Right.
this, because this is where, the things you're drawing, so I draw the pi bond there.
Yeah.
And then I just see that you'll have the ethyl group up here and the methyl here.
Mhm.
And then over here you have a methyl and a hydrogen.
Yeah, okay, gotcha. Alright, thanks.
Is that E or Z?
That's
E for E.
Alright, so
I don't know if I noticed now.
with 7, I'll give you guys like, what's the time left? 5 minutes, and then I'll just start assigning you guys as well. And I think they go on like, I think that one's like regio specificity, and like the regio selectivity.
I think
is, like,
regio
there's like the
selectivity.
HBr, like say for example, it's attack like carbon cation.
It's reinstating the membrane.
Well, so I think regio selectivity is just like when, like technically you could get either a Hoffman or a Zaitsev, but it's just like by the nature of it, it's gonna give you, it's gonna prefer one. When you can make either, and then say like Hoffman or Zaitsev would be your major, but you'll get the other one as your minor. So it's preferring one, it's selecting, say Zaitsev with a
Yeah.
small base, but you'll still get some Hoffman product.
I see what you mean. Yeah, that's another like interpretation of it. I think that one's more accurate than I think.
XSBR2.
You're gonna make me come up with.
What's XXS?
XSSS?
Yes.
No, it's supposed to be SSX. It's
SSX.
Snowboarding.
Yes.
That has to do with X-Men.
Such an idiot.
No, I think you only have like, if you have XSBR2, it would just make a BR on 2 BRs, right?
Huh?
That would move it on, right?
You make
Yeah.
2 geminal products.
Yeah.
2 geminal products?
Or
Oh, 2 on each
two
side.
geminal products, yeah.
Oh, yeah, okay.
Are you guys all done with the whiteboards? I'll start erasing for you. Yeah.
I'm sure.
Did we do halogenation of alkynes?
We didn't.
You skipped that.
CL2, CCl4.
No, just like BR2 to an alkyne.
Oh, no, we didn't. We did this with HBr.
Yeah.
So what was?
Wait, what was CCl4? I
For,
decided that.
like for,
It's the solvent that CO2 is.
So it just makes a bunch of CLs everywhere?
Depends if it's excess or not.
It doesn't say excess, so then therefore it would just make.
Assume one
What
equivalent
you
if it
do
doesn't say excess.
Adding excess purity, right? Because you'd be
Hydrogen
halogenating.
bonds to halogen. would
Yeah, because
be
that just means like
used to
it'll keep going if you
hydrogen.
can. You're gonna do a single bond. But I'm not, I don't
So
even know.
it only makes a shit ton when it's excess combined with
Well,
CCl.
'cause I didn't, I wasn't sure if you
But-
Excess
No.
halogen with CCl.
Just like.
But then it
adding
only does
halogen.
like, it only does
But
Adding
keep in
halogen
mind, it's
to a-
only one side, there's no, this is just
alkyne.
hydrogen.
Right, so if one side's doing that, then it would be a shit ton if
Do
like,
HBr
there's two
stuff.
sides.
Yeah, do HBr stuff.
No, it's doing to both
I
sides,
think I read it
here
on
and
my
here.
book. I think what it does is just like. breaks
No,
the
I'm
chain
saying
to
on
the
our
R, but I think
example,
it's
we have
just
one
like
C
kind of
here, one C
useless.
here, this
Yeah.
one's just a hydrogen.
You just get
Yeah,
like
but
carbon-
still going
carbon
to-
everywhere.
Well, it has to be.
Well, well,
NA,
that's what it'll
well, I thought,
end up
so
being.
that's an NA and NH3 has to have the L?
Yeah.
Or does it make L or just necessarily have
It
to?
doesn't have to have the L.
But as long as it has an
Two
N.
bromes
Yeah,
on the
let's
side.
have NA and
Because it goes
NH3.
Markovnikov.
Okay.
And so it'll just like
Yeah,
go
like-
one side,
So,
and then it'll keep adding
you
to
guys want?
that one, because now it'll be more
Right.
substituted. So-
Whenever you're ready, you can do that first board.
Okay. You know.
Fernando, you can do this board.
What is that?
Corey, I'll give you this board right here. And I put the letter that you're supposed to do. It's supposed to be an A. I have bad writing, so it look like a 9.
Does.
It does, but doesn't anything look like everything?
No, doesn't.
And then Corey with the hat. You could do this one. And I'll just call you OC, original Corey. Better?
You drew my I drew my CL2, CCl4. So if you're just doing it once, does it,
This and DMS is the same thing, right?
that would just
For
make
your
it
ratios, yeah.
still a pi bond?
Yeah, it's still a bond, because we don't have an H to make the other,
Serial?
basis, right?
These are all number 7, right? Or
Yeah, the tree. I mean, if there's no MCP, if there's no just MCPBA, then it would just do the O right there. But if it's H plus, so pronate the H, pronate the O and H.
So we're gonna go over it. Who did that? Oh, it's Alex, right? We'll get back to that one. Mark, can you go over yours right there at the very bottom?
Hell yeah!
It is like sucking up the water in me.
Okay.
So this did that.
This did that.
Alright.
So what was your original,
I forgot that I like Cheetos.
This, the original.
that was your original, right?
Yeah.
So O3 and H2O, what does it do?
It
For
does,
breakfast.
Which is,
it's like a.
Turn on my macros.
hey, you guys mind
Hey.
giving Mark your attention real
Hey,
quick?
look, attention.
Thanks. Alright, so one more time?
So it does oxidative cleavage.
Okay.
And if it has a 3, an alkene, then it makes an OH. Otherwise, it's just an H.
Like some carboxylic acid. What does everyone think? Look good?
Plus.
I can't see it.
That's not necessary.
Yeah, it's not necessary.
Sometimes.
It's never necessary.
If you want carbon dioxide.
Yeah.
Alright, so
Poisonous
then,
though.
your second one, NaNH2 and ethyl iodide.
Alright, yeah, so it takes off an H and then it adds like this and the I pops off. Does that. Basically it just builds stuff. So I used to cussing, those things I feel like I have to like hold my cussing in.
That's all right.
Yeah.
That's carbon chain.
Yeah,
He's like 5 or something.
that's true. Yeah. I'll use cherry blossoms.
Cherry blossoms worse.
And then I wasn't sure about this one, but I guess that it double bonds to the O. You were kind of helping me on that a little bit, but
Are
I
you
don't
doing
really
the
know
blue
it.
ones or the
But
green?
cherry blossoms.
He's doing the very bottom ones.
Oh, these.
Yeah, I got skipped.
Oh, yours was the top one? Okay, I thought that was Alex, my bad. I'll put you next right now.
That SpongeBob episode.
Okay.
I'll put you on hold.
Alright.
Okay, so,
Look good?
yeah. What does everyone think of his answers? Look good?
Last one.
Which one's the answer for the first one?
Answer for the first
This
one?
one's first. This is the second. This is the third. And that's for my name.
Why is there so long a carbon?
That's one's the aldehyde, right? The bottom one,
It should be 1, 2, 3, 4, 5, it's a pentane. No, it's on the back page.
right? And the ketone is on the
Back side?
Yeah.
Robin?